Interference control in an engineering context is extremely important. Here, as an example, you can see how, in defining the reinforcement bars on a foundation footing, a number of aspects were not taken into account, and as a result, in a very short time, more than 1,000 interferences were generated. Now, the ability to anticipate them thanks to our clash detection function, which I remind you can also be quickly accessed using the keyboard shortcut CD, is extremely important. On the other hand, I'd like to point out that Allplan's clash detection, when it generates these kinds of red cubes, attaches a whole series of information that I need to classify the type of interference, whether it's a hard clash, a soft clash, or something that doesn't even need to be considered. Among this information, I'll also have the option, if necessary, to add comments to invite colleagues to resolve the issue or to see which components are involved, specifically which is component A and which is component B that directly triggers my clash detection. To this end, I have prepared a very brief example for you in which you can clearly observe the presence of reinforcement bars, as well as a series of inserts located at the base, which are used to directly anchor my column to the horizontal structure. Everything can be easily checked from the object palette, and then by calling up the CD function, that is clash detection, pressing Ctrl A and running an initial check, I notice that there are currently no clashes of any kind within my model. At this point, we will intentionally create an error, and to do so, I will carefully move all of my inserts toward the center in order to deliberately generate an interference between the inserts and the reinforcement bars. So by using the resize function, I apply a deformation factor that causes the elements to converge toward the center. We call up the clash detection function, so CD, and then we proceed to configure our custom clash detection. Let's name it, for example, I want to check for clashes between the bars and the inserts. So we will select reinforcement bars and inserts, meaning I won't consider other types of elements. At this point, I decide what type of check I need to perform, only hard or both hard and soft clashes, and I set a depth range of 2 millimeters and 3 millimeters in this case. We click OK. We simply choose the clash we just customized and display all of the results directly within the information palette. In here, I find a whole series of important information. Among other things, I also find out exactly which specific object is going to collide with the other. So on one side, we have the reinforcement bars, and on the other, we have the inserts. As I was saying, each of these elements comes with a multitude of information. So potentially, I could even tell it, no, look, for me, that's not a clash. At this point, directly from here, I can tell it, show me what generated that clash. Element A is the reinforcement bar, while element B, on the other hand, is the insert. Or show me both elements involved, and so Allplan will select both objects for me. At this point, let's try to understand why a soft clash was generated, and to do that, I need the depth information. I can search for it directly in this drop-down menu, or simply by typing a few letters that contain the word depth. I can scroll horizontally within the table until the column is suggested to me directly. The clash depth column. So as you can see, it is between 2 and 3 millimeters, and that's the reason why that type of clash was classified as a soft clash.